Hi everyone. Today we are going to present our project, the Smart Hospital Ward Monitoring and Infection Diffusion System. This is for our course Fundamental of Programming Assignment 2. Our project combines patient health tracking with data analysis and simulation tools. Let's look at how the entire system works from the start to finish. It basically follows a simple pipeline: input, double OP, analytics, simulation, and visualization. First, we have data input. We can either auto-generate 50 random patients using NumPy or read them manually from a CSV file. Next is the double OP layer. Every patient gets turned into an object in our code, which immediately checks if their data is valid. Then comes the analytic engine. We use NumPy and Pandas to calculate average and create structure summaries for the hospital ward. Finally, we have the simulation layer. We create two visual models. First one, 1D walk to track down a patient moves down a hallway. Second one, a 2D grid to show how infection spread across the world. Now, let's talk about the structure of our code. We use inheritance to keep things organized. At the top, we have person, which is an abstract base class. This means it is just a template and cannot be created on its own. It forces all subclasses to include the basic info display function. Under that, we have patient, which adds specific details like their word, temperature, and the heart rate. From patient, we split into two specific types: regular patient for standard rooms and critical patient for patient in the ICU who need urgent alerts. This setup makes our code super organized and easy to expand.
Hello everyone. Today I will talk about how we use coding to keep patient information safe. First, let's talk about encapsulation. This means protecting data with rules. These rules stop wrong information from entering the system. For example, the program knows that a normal human body temperature should be between 30-45 degrees Celsius. It also knows that a person can be 99 years old. If someone enters wrong information, the system will reject it automatically. This helps keep the data correct and safe. Next, how do we get patient data? We can create fake patient data in two ways. One way is by using tool called NumPy. We can quickly create 50 random patients. The second way is by reading information from CSV file, which is simple text file made by a person. With these rules, the system can also find critical patient easily. For example, it can identify patients who have fever higher than 38.5 degrees Celsius. In conclusion, this method keeps a program organized, find mistake early, and help us manage health data safely. Thank you. That's the end of my part. To continue this presentation, I will hand over to Venusha.
NumPy statistical analysis. Once we have our patients, we run basic statistics on their temperature using NumPy. The mean and median both come out around 37 Celsius, which makes sense because we generated the data from a normal distribution center at 37. When the mean and median are the same, it confirms that the data has no skew. The standard deviation is about zero point 0.7, exactly matching the value we set when generating the data, which proves our model is working correctly. And the minimum to maximum range of 30 to 45 Celsius isn't just a statistical result, it's a hard system rule enforced by the proper setter. No value outside that range can ever exist. Pandas data analysis. After statistics, we move all our patient data into Pandas data frame. Basically, a table with columns for name, age, ward, temperature, heart rate, and infection status. From there, data frame head normal brackets give us a quick preview of the first 5 rows, and data frame describe normal brackets give a full statistical summary of every numeric column automatically. Then we use group by a by to break it down by word, showing patient count, average temperature, average heart rate, and infection cases per ward. Finally, we export the whole table to CSV file so it can be saved, shared, or open in Excel. Samindu will continue our presentation. Thank you.
Thank you, Vamsha. Next, I'm going to discuss about word-wise analysis. As you can see the presentation, this table shows the actual output of our group by analysis across all four wards. General wards A and B each have around 13 patients with average temperatures of 37 Celsius and heart rates in the high 80 seconds, both within normal ranges. The ICU has about 12 patients but shows the highest average temperature at 37.3 Celsius and the highest heart rate at 91 seconds, and the most infected patients are at around 5. Step down unit is the most stable with the lowest heart rate and fewest infections. So the key insight here is that the ICU stands out in every metric, which is exactly what we expect because our system automatically sends the sickest patients there. Moving to next slide. Random walk simulation. This simulation models how an infected patient moves through a hospital corridor. Each of 100 steps, the patient randomly moves one step left or right. Then we stack all the steps together using consume to get the full position timeline. Then on the chart, the shaded zone between -5 and the +5 represents the safe contaminant area. If the path drifts outside that band, it means the patient has left the monitorized zone. A green star marks where the patient started, and the red X marks where they ended up. The seed value of 42 makes sure every team member gets the exact same chart. Thank you. Next, Nipun will continue the presentation.
I'm Nipun Pereira. Let's talk about infection diffusion simulator. So in this simulator shows how an infected can spread across the hospital ward. Imagine a grid, 20 rows and 20 columns. So it's like a chessboard, and each square represent a hospital bed or a random spot in the ward. So that gives us 400 positions in total. So now let's move on to the simulation. So first of all, we get one infected person and placed in the middle of the grid. And the special thing is other patients are really healthy. But now, then the simulation runs step by step. So each step, infected in each step that we get data from the infected patients, not from the infected patient, the other surroundings, the other neighbors of that infected person, we get checked. For an example, if the nearest person, so the infected persons, the other around guys, neighbors, left side of the person, right side of the person, and below and above. We also monitor those guys of uh, health monitoring, and we pick a random number, and if that random number is below, we get in here 0.35. It means 35% of getting chance of infection. So if the 35 number 0.35 or 35% of chance, you can change it what you want, but it can be changed. But if the 35% or if you get over the 35%, it means you get infected highly. It gets lower means the inspection spread lower. The higher the number is, higher the spread percentage. The lower the number means lower the spreading percentage. So this is also used in real world some solutions. So in this slide, you can clearly see some random four image. This is not random four image. This is the result of that spreading thing. So we use here in matplotlib to create 1x4 subplot thing. So it means 4 panels in one figure. So each panel shows a grid at a different points in time. For example, this first figure is in step 1, other figures in step 5, and others 10, and the last figure is step 3, step 20. So in here you can see random colors, yellow, orange, and red. So I can explain that also. So in here we use uh, YLORD color system. So it stands for yellow, orange, and red. We call with a value 0 means healthy. Healthy shows in a yellow color. A cell call with value 1 means infected. It shows in red. So the times goes and goes. You can visually see the red spreading towards from the center like a wave. So how we output this data? So this code save as a figure PNG image, nearly 300 to 350 dpi, which gives us high quality clear output and makes it really easy to analyze for the controlling sum. So these are the summary of this presentation. Thank you for